Hello everyone, welcome back. I'm now going to do question 10.2.2. This is from the November 2022 paper 1 exam. Now for 10.2.2, they're asking us to calculate the probability that you will open the lock at the first attempt if it's given that the code is firstly greater than 5,000 and the third digit is 2. Now, we need to take these things into consideration along with the restrictions that I've highlighted in the top line. We now again have to come up with a 4-digit code that satisfies all of these conditions. Now, guys, remember that we have these numbers to choose from: 2, 3, 4, 5, 6, 7, 8, and 9. We may not choose 0 or 1. That was given in the first question, and digits may not be repeated. Also, this code must be even numbered. That means that the last digit has to be an even number. So the last digit either has to be 2, 4, 6, or 8. Now, the fact that they're telling us here that the third digit in this code is 2, that means that this digit is going to be 2, right? That is going to be fixed. So there's only one option for the third digit. Now, guys, since the digits may not be repeated, if the third digit is a 2, that means that I now may not use 2 in any of my other positions in this code. Now, the fact that they've said that this code must be greater than 5,000, that adds another layer to it. That means that the code has to start in either 5 or 6 or 7, 8, or 9. Because if you have a number, a 4-digit number that starts with any one of these numbers, it will be a number that's greater than 5. Now, I am going to think of all of these different options. The first option is, what if my code starts with a 5? Right? Let's say my first digit of this code is 5, and remember they told us that the third digit has to be 2. That means that there's only one option for the first digit and there's one option for the third digit. How many options do I now have for my fourth digit, given the fact that it has to either be a 4 or a 6 or an 8? I have 3 options for that last digit because that will then give me an even number. Now, if I have an even number there, I've now used 3 of my digits of the 8, or 3 of my numbers of the 8 numbers that I had to choose from. So that means that I'm only left with 5 numbers to choose from. So that is actually saying that there are 5 times 3, so 15 codes that will start with 5 that will satisfy all of these conditions. So now I've thought about codes that start with 5. All right, so let's say the code starts with 6 and the third digit still has to be 2. There's one option for the first and one option for the third digit. Do I now actually still have 3 even numbers, right? Because now my first digit is a 6. Let me take away that over there. How many even numbers do I now actually have for this last slot? Well, I can use 4. I can't use 6 again because it's the first digit there. And I can use 8. That means that I actually now only have 2 digits to choose from that will make this code an even numbered digit, an even numbered code. That again leaves me with 5 numbers to choose from because I already have used 1, 2, 3 numbers. So that means that there are 5 times 2, which is 10 codes starting with a 6. Let's do the same for 7. So if my first digit is 7, my third digit is 2, I have one option. Since my first digit now, 7, is an odd number, that means that I'm still left with 4, 6, or 8 to use in the last slot. So I have 3 digits to use for the end there, and I'm still left with 5 numbers to choose from for that third slot. You'll see that some of these repeat, and if you notice that at the beginning, you absolutely can do this calculation in a shorter way. I just want to show you step by step the thought process. Now, if the code starts with 8 and has a 2 in the third digit, again, we have one option for the first digit, one option for the third digit. Now, since 8 is an even number, I now only am left with 4 or 6 to choose from for my final digit. So now I only have 2 digits to choose from, 2 even numbers that will make my entire code even. And because I've used 3 numbers, I'm only left with 5 to choose from. These 10 codes all will start with 8. And finally, how many codes are there that start with a 9? So if my 9 is my first digit and 2 is my third digit, one option for that 9, it has to be a 9. One option for that 2, it has to be a 2. 9 is not an even number, so I still can choose from 4 or 6 or 8 for that third or that fourth digit, that final digit. There are 3 options, and then again I have 5 options to choose from for that middle digit, that second one. So how many codes are there now in total? If I add 15 and 10 and 15 and 10 and another 15, I am left with 65 codes in total that satisfy the conditions stated in 10.2.2. But guys, they've asked for the probability that you will open the lock. So how many codes are there that are greater than 5,000 with the third digit of 2? 65. Over how many codes are there in total? 840. So that is the probability. So therefore, 65 over 840, which is equal to 13 over 168 if you simplify it. Please do remember to simplify your